Good morning, everyone, and thank you for joining us today. My name is Bertrand Irisu. I am the CEO and co-founder of Brainome. It's my pleasure to welcome you to our sixth and last of the series webinar on the benefits and application of our measurement-based approach to machine learning. Before we get started, I'd like to remind you that we actually had two concurrent webinar series, which are all completing. The last one being today with easy apps and tiny deployment. But you can access all the recording on our website at brainome.ai/resources/webinar-video. If you have any questions, please put them in the Q&A channel, and we'll answer them at the end of the webinar as well. So our topic today is about easy ML ops and tiny deployments, and will be presented by Lynn Chase. Lynn is our VP of Product Management at Brainome, which means she's laser focused on making our Daimensions users successful. She's earned her PhD in computer science at Carnegie Mellon in 1997, and she's been working on making AI software useful in the real world ever since. She joined us at Brainome a few months ago, bringing with her an extensive multi-decade track record of successful development and deployment of AI technology in business environment. So Lynn, without further ado.
Thank you, Bertrand. I'd like to start today's discussion about what ML Ops looks like with Brainome's Daimensions software and what deployment looks like with our software by starting by taking a look at what the traditional machine learning lifecycle is. You'll see this diagram all over the place, and those of you who are active in the field will recognize it immediately. We start with data preparation, and that involves sourcing data from typically multiple locations, and then doing cleanup, cleansing, pre-processing, and then moving from that preparation phase into what is often and typically a very extensive modeling process with a lot of computation, using a lot of data, and taking a lot of time. Then after a model is built, models can be evaluated, and the evaluation is done after the model is built and typically on some held out validation test data. And when a satisfactory outcome has been achieved, we move to deployment and to monitoring. And then the cycle continues around in a circle. Let's take a look at this in a little more detail. In the traditional machine learning world, with the tools that are currently available before Brainome brought Daimensions onto the scene, really the only way to evaluate a model was to measure validation test set accuracy. And so that's a somewhat limited view of what a model can do. You can measure correctly classified instances, and you can do that on an independent test set, but you don't really have a measure to look at how general the model is, how well it's going to be resilient when faced with real world data in a deployment. Using current techniques prior to Brainome coming onto the scene, there wasn't a direct way to measure generalization. It is possible with current techniques to talk about model complexity if you think about the number of layers in a neural network or the number of parameters in a model. And it's certainly the case that the industry, the community as a whole, is working from a point of view of more is better. More data is better, more parameters are better, more cycles to train those parameters is better. And that's pretty much what you've got in today's world. So it is the case often in the traditional life cycle that after extensive preparation and heavy duty modeling, you do some test set validation accuracy evaluation and end up going back to either manipulate the data further or manipulate the model further. So you can typically see that happening maybe 2 times, maybe 3 times. But in particular, because the modeling is expensive and takes a long time, you don't see people doing lots and lots and lots of iteration. It's not built into the way people think about doing things. So at some point, after doing some number of relatively expensive cycles here, you do move on to deployment and then into a monitoring phase. But then again, at the monitoring phase, the only tool available is accuracy. So more data is collected and some additional data is labeled and accuracy is remeasured during the monitoring phase. And then the cycle continues. And what that ends up causing is a behavior that looks like this, where an initial model is deployed, and then its accuracy starts to drop a little bit over time. And at some point, the decision is made to retrain and redeploy a new model. Accuracy can go back up again, and it starts to drop again. And you see this kind of hump-like behavior of refreshed models deployed over time. So that's kind of the state of the world. And by the way, thank you to Joel Thomas and Clemens Mewald for this diagram. I got that from them. The difference between what's going on in the traditional current state-of-the-art machine learning process versus what happens with the Brainome machine learning lifecycle, there are a couple of differences, and I would like to go through them each in turn so that we can compare and contrast what happens. So particularly, the first thing that happens is that we don't go from preparation directly into modeling with Brainome. We actually go directly to evaluation. Now, we've covered in many of the previous webinars what it is that measuring learnability before modeling is about, and what is the new math, and what are the new algorithms that Brainome and the Daimensions tool are bringing to the game. But so if you haven't seen those webinars, I highly encourage you to go back to our website and look at the archive and watch the Core Tech webinars in particular, where we go through what exactly we mean by measuring learnability and how we do it and how that's different from what anybody else is doing. But the bottom line is, from an ops point of view, is that we move directly from preparation to evaluation. And in fact, the whole process that we encourage you to use with our tools is a tight, fast iteration loop between manipulating the data and evaluating its learnability. And by manipulating the data, we mean gradually increasing the amount of data you're collecting and labeling, and looking very carefully at what the data features are and which data features are helping you. And we've gone over that again in the previous webinars in detail. In particular, there's a benefits and applications webinar called Superpowering Your Data Preparation that I would encourage you to watch. The bottom line is, with Brainome's solution, we measure the learnability of data against different types of machine learning models, such as decision trees and neural networks, and we do it before we build any models. And the kinds of things that you can learn when you're doing that tight, fast, iterative loop evaluation up front before you build is to know when you have enough data, when you have the right data features, which of the data features have real predictive impact, knowing whether or not you're going to overfit, knowing which of the types of machine learning models that we support, which right now is decision trees and neural networks, will work better with your data, and getting an upper bound estimate on how long it would take to train if you chose one or the other of those models. So again, the whole idea is that the core way to approach the machine learning lifecycle when using Brainome's Daimensions software is to start with this tight iterative loop between preparation and evaluation. Then we can move on to modeling and deployment. The next big difference, though, is where is the monitoring and how does monitoring work? And here we're going to take a look at what happens differently between traditional machine learning operations and for deployment and monitoring, and what goes on with Brainome. Now, let's start by looking at what happens with the traditional machine learning ops. In the traditional approach, or the current sort of industry normal approach, models are saved as complex and they're complex proprietary binary files. So depending on the tool, you get a different proprietary binary representation of the models. And furthermore, those models are typically spread across multiple files. Typically, there'll be one or more files for architecture and topology, and separate files for the trained parameter values. Also, pre-processing and cleaning or cleansing of the data happens in multiple separate steps when you use the state-of-the-art tools. Some more differences. When deploying, Deployment has to be done using a mix of different kinds of model files, for instance, the architecture and topology and trained parameter value files, and scripts and pieces of code to make everything work together. The complexity of the way deployment and, in fact, monitoring plays out in today's world causes the problem that reproducibility can become an issue. So it's complex enough and there are enough moving parts and it's a hairy enough beast that reproducibility is in some cases an issue. There's also the case that main memory or RAM management is a significant limiting factor because the data that's in the architecture and topology files and the trained parameter values and all of the additional support code all have to fit into main memory and or at least be swappable in and out using some pretty heavy duty machinery. And so RAM management is known to be a significantly limiting factor in the deployment and the maintenance and monitoring of state-of-the-art models. And this causes monitoring to be an additional separate set of processes that are distinct from all the previous processes for preparation, modeling, evaluation, and deployment. So monitoring is its own beast in today's world. So let's take a look at what goes on with deployment with Brainome in comparison, and then we'll go on and talk about what happens with monitoring with Brainome. So with respect to deployment, I want to remind you, and this is something we have gone over in previous webinars, but I'm happy to repeat it here. The Brainome is a compiler. So it takes data in and the Dimensions software is a compiler, and it writes out a compact standalone piece of code in Python that is a predictor. And that compact standalone piece of code does everything. It does data preprocessing, it does prediction calculations, and it's just a piece of code. There's no special model file, there's no additional pieces of anything that you need other than the predictor that gets written out of the compiler. So with Brainome, this simple Python output, it contains every step for the entire machine learning pipeline in one single executable piece of code. And that means that the models are run from hard disk. They do get loaded into main memory, obviously, to execute, but they're compact. And so space management becomes far, far less of an issue compared to how the state-of-the-art currently operates. Version control and maintenance and deployment are exactly the same with these Python predictors as they are for any other kind of software. So no new category of deployment techniques or deployment team members or deployment processes or deployment standards or monitoring for that case need to be added. It's just deployment is handled like you would handle any other piece of code using all existing ops frameworks. And that includes everything, version control, maintenance, and as it turns out, monitoring as well. Deployment engineers also have the option to open up the Python code and pull out useful pieces if it's only certain pieces that need to be integrated elsewhere. So if a deployment engineer wants to pull out the preprocessing and data cleansing software, he or she can. If the deployment engineer wants to pull out just the predictor, the heart of the code, it's a very small piece of code. It just sits right in the middle of the Python and it can just be pulled out and again used as source code would be anywhere else. So you can use GitHub on our predictors just like you would on any other code. It's also the case, and this is kind of a side note for specialists who care about it, but we can also compile these results, the predictor results, out of the Daimensions compiler into an ONNX format, which PyTorch and TensorFlow use to support modeling, to represent their neural network models. And so if desired, the ONNX version of the output from our compiler can be integrated into other downstream systems as well. So that's how deployment works with Brainome. And it's super simple, it's super compact, and you just get this piece of Python code and use it like you would any other code. So that's a pretty straightforward story, but let's take a look at what goes on with monitoring with Brainome. And to do that, I want you to recall in a previous webinar and in general, the story of data drift. And data drift is what happens when a model built to represent the patterns in some initial data to which it was exposed for training stops matching completely the operational data that it's being exposed to and deployed into the world. So data drift overall is something we all care about very much in terms of the real world applications of supervised machine learning. And again, data drift is what causes this refreshed model bounce that we talked about earlier in the conversation. So there are some problems when you're doing monitoring and trying to handle data drift in the traditional machine learning world. One is that the only option you have is to build a new model and then remeasure accuracy. Building new models is typically very expensive and time consuming, and it can actually be error prone. And once you have your new model, you don't have any visibility into what changed, either in the data stream coming in from the operational context or in what's inside your models, the new model that you changed. Once you have your new model, you have no visibility into what changed. Monitoring is super important, obviously, but we want to position you to get real information, not just the information you get from measuring accuracy. So just like with the traditional machine learning lifecycle, we went directly from prepare to evaluate. We're also going to go directly from deploy back to the top of the cycle. Let me show you what that means. We're using Brainome and using the measurements for learnability that are at the core of everything that we do. Monitoring, the process of monitoring, the math of monitoring, the algorithms of doing monitoring are the same as the processes that were going on during preparation, the fast iterative upfront prepare evaluate cycle. The processing that you need to do to monitor is exactly the same as the processing you need to do upfront when you're in this tight loop. And so that means that while you're doing monitoring, you don't just get information about accuracy. You get information about which attributes are mattering or starting to matter or stopping in terms of their ability to be predictive. You can get flags on whether or not there's enough new data coming in to make a difference. You can watch what's happening to generalization and resilience as the operational data is working on the model that's currently deployed. You can watch what's happening with respect to capacity progression. You can see how many parameters are now needed to model the data that's coming through, and you can see whether or not you're starting to overfit with what you're doing with your modeling. So the point here is that when you are monitoring using all of the learnability measurements that Daimensions brings to your systems, you're doing an observe evaluate loop. It's the same computation as the original prepare evaluate loop, but now you're observing and you're doing the exact same computations. And so that means that we can think about the overall Brainome machine learning lifecycle as looking like this. Either prepare or observe in a tight loop in evaluation that's happening, and then pass through modeling and deployment and repeat. And on top of all of that, the key is that the evaluations that you're able to do are much more powerful than working with just raw accuracy scores, because you can know when you have enough data, the right data, which features are important, whether or not overfitting is going on. And those are very, very valuable things to be able to evaluate. So in summary, let's just recall that Daimensions is a compiler, and it does all of these cool things. It models based on the learnability measures that we've talked about extensively, and it creates smaller, faster models that are more explainable. And in the end, the machine learning lifecycle is simpler and more powerful. And that is what I had to tell you today.
Great. Thank you, Lynn. Got a couple questions right now in the Q&A. Let me take the very first one. This one is coming from Arjun. Arjun is asking, why are your models smaller? I don't think we covered that today.
Oh, we didn't. No, there is a whole webinar on this. Well, actually, the smallness is covered in the Cortex series, and also in, I believe, what was the 5th benefits and applications webinar. But I can't answer the question here totally. The point is that using the the learnability measurements that we have, we're able to build our models from the ground up. We don't have to start. Pretty much everybody, I guess everybody else, starts with a model that has a number of parameters in it. And then your job is to find as much data as you can and as much compute as you can, and tune those parameters as best you can using an accuracy measurement. What we do is different. We build from the ground up. So the model that you're building, we don't know until we start the measuring process how many parameters we're going to need for the model. And then we can measure and tell what's the maximum number of parameters we're going to need for the model. And then as we build the model up from the ground, we end up with typically far fewer parameters than that maximum number. So the point is that the learnability measurements that we've invented and implemented allow you to build a custom-sized model that has the right number of parameters to learn the patterns that are in the data that are presented.
Okay, thank you. I have a second question coming from Mike, who's asking, what are the software and hardware requirements for deployment?
Oh, for deployment, great question, Mike. I should have mentioned that earlier. They're very generic and typically not very big. So any hardware that can execute Python will work. Typically things like laptops, but we also have deployments on mobile phones, and we even have a deployment on a Raspberry Pi. These models are small, they're compact, and they run fast.
Great. Last question coming from Lisa. What kind of models do you support?
Oh, thanks, Lisa. At the moment, just neural networks and decision trees are supported. We are finding that because of the power of that tight prepare, evaluate, or observe, evaluate loop, that those are the only 2 kinds of models. People can do an enormous amount with those 2 kinds of models, given that we've got this very rich evaluation and measurement scheme in place now. But we do have planned in the future, no dates on it yet, but we are in our R&D pipeline looking at Gaussian mixture models and random forests as well.
Great. That's all the questions we have. Before we end our session, I'd like to encourage you to try our demo of Daimensions on our website at, well, you can find it on our website, brainome.ai, and click on the demo button. You can also register to access more of its features as well. This was the last of our webinar in this series, but if you missed any, recording of previous webinars are available at brainome.ai/resources/webinar videos.